Hello guys and welcome to our programming part of our k nearest neighbors. So in the previous session we just saw about the explanation about k nearest neighbors and how actually the k nearest neighbors are chosen, and we also learned about what is the optimal value of k to be chosen for our programs. So what we'll be doing is we'll be using a simple data set that is nothing but our iris data set. So what is iris data set? How the iris data set is being involved in this particular program, we'll try to understand. Then we'll be implementing our k nearest neighbors. So to start with, we'll just understand what is our iris data set first. So iris data set is nothing but the data set of flower iris. So iris is nothing but a kind of flower. In iris we have four types. So what is the four types of iris flowers we have? We have Centosa, versicolor, virginica. So these are the types of flowers that we have. So these type of flowers are nothing but the different types of iris flowers that are available. So how are these iris flowers different is pretty simple. So they vary with respect to the petal width and petal length as well as sepal width and sepal length. So what is petal of a flower? So petal of a flower is nothing but the colored portion of the flower. So each and every type of our iris flower varies with respect to petal length and petal width. So you can see here we have petal lengths varying from 1.5 to 4.5. So these are nothing but in centimeters. So they are measuring the length of each and every petal and sepal. So what is the length of sepal and what is the length of petal? So petal is the top portion of the flower. So this is the petal length and petal width, and below we have the sepal length and sepal width. So based upon this, we can form the class of our iris flower. That is nothing but we have four classes basically. So basically we have four classes, but this data set we have will take into consideration that is nothing but three classes. That is Centosa, versicolor and virginica. So Centosa, versicolor and virginica are the three classes we will be using in this data set. So this data set will have three classes: Centosa, versicolor and virginica. So these three classes of flowers vary with respect to our petal width and petal length as well as our sepal width and sepal length. So we have four parameters, that is nothing but sepal length, sepal width, petal length and petal width. So these are our four parameters that we'll be considering for programming our data. That is nothing but these will be forming our X data. So X is nothing but the four columns of data that we have. So Y is nothing but the label. So since this is a classification algorithm, we need to classify our data into how many parts? That is nothing but three parts now. In previous cases we just had two, that is either 0 or 1. But here what we are trying to do is we are able to classify the data into three parts, that is Centosa, versicolor and virginica. So how are you differentiating it? So Centosa has basically sepal length from 4.9 to 5.1, so sepal from 3 to 3.5, petal length of 1.4 and similarly petal width of 0.2. So the other flowers are quite larger, 6.5 of sepal length and 3.5 of sepal width, 4.5 of petal length and petal width respectively. So these are nothing but the measurements or dimensions in centimeters. So with this help of the X data, which is nothing but our four columns, which is telling us the sepal length, sepal width, petal length and petal width, we are able to predict our Y. So what is our Y? Our Y will become our class. So class here, unlike our previous examples, this is a trinomial classification or three classes classification where we have three datas, that is nothing but three classes which we need to classify, which is Centosa, versicolor and virginica. So this is the data set that we will be using to actually program our data. So what we will be doing now is we will be trying to import the data set not through a manual method of a CSV file, but through an online link. So we will use an online link to import our data, then to program it and to get the results. So this is the thing that we'll be doing right now. To start with, we'll import the libraries. So what are the libraries that we need? You already know that is nothing but we need NumPy as NP. So this is nothing but giving an alias name. So we are importing NumPy library. So then import matplotlib. So why matplotlib? For plotting. So I don't think you need matplotlib here, but you need pandas library, pandas as PD. So these two libraries will import. One is matplotlib and the other one is pandas. So these two libraries we'll import. Then what we'll do is we'll use a URL. So what is this URL telling you? So URL is telling you nothing but the place where we can get the data set. So there is two methods basically. One, you can directly download the Iris data set and use it in like the similar examples when we used to read the CSV using the .csv files. But when we have a URL, you can directly use the URL to actually access the data. So as you can see here, so when I type in Iris dataset, so we'll go to the first one, that is archive.ics.uci.edu. So I already told you uci.edu, that is nothing but that is the library for finding out the various datasets. So if you want to find out the datasets, that is nothing but your Iris dataset. So you can use this particular dataset for example. So this is nothing but a repository where you can find a lot of datasets. So this is the place where you can find a lot of datasets. You can go to the data folder. So where you can find out the datasets. So this is what you can find out. So what you can directly do is there are two methods here. So we need this Iris data, which is nothing but the data containing each and every of our examples, that is our CSV file containing all the data. So this is one place where you can get. Or if you don't want to download that, you can copy this URL. So this URL you can copy. So this URL is basically leading to this particular data set. So you can download a CSV file and use it, or you can use this particular URL also to access your data set. So what I will do is I will copy this URL. So then URL is equal to, within double quotes I will type the URL. So since I need the Iris data, iris.data also I need to type in here. So iris.data I typed in here. So what did I do now? Instead of downloading my data set as a CSV file, so I used this URL to actually fetch the data set. So what is this URL? https archive.ics.uci. UCI is nothing but University of California, Irvine. So this university has collected a lot of data on Iris. So this is the data set that we are downloading. So this will be the URL from which we can download the data set. Not necessarily you need to download the CSV file and use it. So this is also one more possibility that you can use. So this you need to use, that is Iris data, that is the whole data set. So after that, what we need to do is we need to see what are all the column names that is available here. So what are all the column names that is available? So you can see this index, or these are all in the form of web directory. So you can just open the data set. So you can see the data set information. So what is the data set information you have? You have basically 4 columns. So what is the 4 columns? You have sepal length, sepal width, petal length and petal width and class. So totally 5 columns are available. So in the 5 columns, we need to select all the 5 columns that will be required for our whole process. So what I will do is I'll create another data called as names. So names is nothing but my data which has my names of the columns. So sepal length is one column. Okay, then we have sepal width. So similarly we have petal length. So then we have petal width. So we took into consideration the 4 columns. Then we have a column called as class. So these are all the columns that we have in this particular data set. So this is the thing that we'll be using. So we have sepal length, sepal width, petal length, petal width, as well as our class. So this is the data that we need. So these are the 5 columns that we'll be using. So these are all the 5 columns we are trying to use. And this is nothing but our URL, which is the string that we are trying to call. So how to save this in a data set is pretty simple. The same function, data set is equal to pd and dot reads underscore CSV is the function to read our CSV file. So then since we are not using a CSV file here, we'll use the URL, but we will need to mention what is the names of the columns that we need. So names is equal to names, telling that we need all the columns belonging to this list. So this list has sepal length, sepal width, petal width and class. All these 5 columns names should be taken and should be stored in the data set. So make sure that your internet is on. If your internet is not on, it won't be able to read the data set. So what I'll do is I'll use this print data set. So this print data set is telling you to print the data set for us. So this will print us all the data that is available. So if I am successfully connected to the internet, so I can easily print out the data set. Yes, so we have 150 rows, 150 data, sepal length, sepal width, petal width and class. So this is the total data that we have. So you can see that we have successfully downloaded the data set from the internet, and we can even load the data set here with respect to our entire data. So this is very important to understand. So after understanding this, we need to start moving on. So moving on, what we'll do is we'll have our two variables, that is nothing but x and y. So x is nothing but our dataset.ilog. So how many columns are there now? So we have our columns, that is nothing but we have 5 columns. So we'll be considering all the columns except the last column as our x data. So what is our x? It is petal length, petal width, sepal length and sepal width. So this will be my x value. So I can use dataset.ilog colon minus 1. So what is this minus 1 telling you? Choose all the columns except the last column. So your x will store all the data except your last data. You can try to print out the x to see whether x has been printed properly or not. So I'll just load the x data. So it will print out my data set also. Then it will print my x values also. So this is squeezed. You can click on here to see the x data. So yes, so you can see that all 4 columns data are available with respect to x. So x is stored successfully. So this is done. So I can comment out the print statement so that I don't need to print it each and every time. So that is done. So what I'll do next is I'll choose the y coordinates or the y data. So what will be my y data? It is nothing but my dataset.ilog. My value, that is nothing but my last column value. What is my last column? My last column is nothing but my classes. So what will my classes have? My classes will have the 3 types of iris class names, that is nothing but versicolor, sentosa and virginica. So these are the 3 like the classes of iris flowers that we have. So this we can consider here, and we can try to print out y. So as I print out my y value, you can just see the different classes that are available. So you can see iris, sentosa, versicolor and virginica. So these are all the flower classes that are available. Classes are nothing but the thing that we are going to predict. So in earlier cases, we just had x and y, so that is there. But here what we are trying to do is we are able to predict our data into 3 classes, which is nothing but our flower classes. So moving on, so we'll just do the next part. So what is our next part? We will split our data into training and testing. So how do you split our data? We will use our sklearn library. So from sklearn, import, so sklearn.model selection. So .model underscore selection. What we need to import? We need to import our train test split. So train underscore test underscore split. So this is the function that we are importing. So why are we importing this? We want to split our data into training and testing. So what data will split? Xtrain, xtest. Similarly, y underscore train and y underscore test is the data that we have. So we need to split it into different parts. So how will we split? It is train test split is the function. So we'll use this train test split function. So after using this function, what are the things that we are splitting? So we need x and y to be split. So that is done. But we need to mention our test size also. So test underscore size is telling you that how much data is going for testing and how much data is going for training. So I've already taught you that majority of the data must go to training and only the minority part will go into testing. So another thing I need to mention here is nothing but the random state, but I want you to purposefully understand the help of random state. So I won't use random state. I will try to do some iterations and show you how actually the training and testing set data is varying and how I will get different results when I iterate it a few number of times. So this is why I'm not using random state. So if you want your data to be constant, that is nothing but the data which you are splitting into training and testing. So the data which is split is to be constant or not varied among the next iterations. So you need to mention a state that is nothing but random underscore state. So you need to mention that as anything. So if the number that you mention is nothing but the random state. So if you use 112, so once you get that data that is being split into training and testing for 112, the next time also the data that is split will be the same. So it won't vary for the further iteration. So that is what we are doing. But to show you how it will vary, actually if I don't use this, I will tell you that because I'm not using my random underscore state. So now we have successfully split our data into training data, testing data. So we have our xtrain and xtest and ytrain and ytest. So before applying our, that is nothing but our k-nearest neighbors algorithm, so we need to consider one more thing here. So what is the thing that we need to consider here is the concept called as standard scalar or nothing but a scalar transformation. So what is the scalar transformation is important to understand. So as you can see in this particular example that I already quoted, so we have different features here. So what is the different features that we have in x-axis is nothing but sepal length, sepal width, petal length and petal width. So one thing you need to focus here, so sepal length parameters are varying between our 5 and 6. So we have our sepal length that is varying between our 5 and 6. So if I have Virginica as one data that I can select here. So if I have Virginica, so what I will do is I'll take into consideration the features. So this is for Virginica, red is for Virginica. Okay, so then we have that is nothing but green colored for our. Okay, let us consider one feature here. So if we are considering our petal length feature, so we'll consider that as our circle. So that will be divided into 3 categories. So basically we are dividing it into 3 categories. So this we will call it as the petal length. Okay, this we'll call it as sepal length. Sepal length of, we'll call it as Sentosa. So similarly, we can assign different values here. So this is for sepal length of Sentosa. So this is the sepal length of versicolor. So this is what I can do here. So what I have is different representations of petal width of Sentosa, versicolor and Virginica and sepal length of Sentosa, versicolor and Virginica. So if I want to plot these values looking at the data here, so my sepal length of the 3 flowers would be around the range of some 5 to 6. So 5 to 6 meaning that I would have my values right around here. So if I have my sepal lengths of data, I would have my values here. So similarly for different flowers also, I would try to have my values somewhere here. So this is the value that I would have got here. So what I am trying to tell you here is, so we have our data that is sepal width that is in the range from 5 to 6. So that is the value that I have here. So similarly, if I take in another feature, so what is the feature I am taking? That is nothing but my petal width. So my petal width is ranging between my 0.2 to 1.8. So I have my petal width around 0.2. So this is my data that is being split here. So similarly, I have my data around here. So this is the data that I will have. So I will have multiple collections of data here as well. So the main problem that I have here is different features are aligned at different portions of our x and y axis. So if I see my graph, so different portions are, different parts of the data are in different portions. So some are in 5 to 6 range, some are in 0 to 1 range. So what we try to do now is, so if I want to predict my data, so if I have my star that is my unknown value, so if I want to predict my data, I would look at the nearest neighbors around here. So I would look at the nearest neighbors around here and so I would predict it as versicolor. So the main problem is I can't consider this data. So nowhere I am considering these neighbors. So that is why I am having a great problem here. So only the data that I have selected with respect to the petal width I am able to select, or if I place my star here, only the data with respect to sepal length I can choose. So the rest of the features are ignored because different data is in different value range. So you can see petal width is in range of 0.2 to 1.8 for different flowers. Similarly, petal length is from 1.4 to 5. Sepal length is also from 3 to 3.5. So sepal length is from 5.1 to 6.4. A lot of variation is there. So I'm not able to map in all the features. So if I consider only my data, so I can map in only one particular feature or maximum 2 particular features, but not all the features. So that is why we need to transform our data. So what is meant by transformation is pretty simple. all the data I will transform it to a lesser value. So what I will do is I will keep my maximum range as 1. So maximum range will be 1. So my maximum value is nothing but 1. So what I will try to do is I will fit my all data to 1. So if it is around 6.0, it will be nearing to 1. So the maximum value I will range it from 0 to 1. So I will fit all the other data, that is 5.1, 3.1 to 1. So that is what I am doing. So what is scalar transformation? Scalar transformation is nothing but fitting my data to a single range value. So since I have different ranges of values starting from 0.2 to 6.5, but I need all these values either expanded or contracted to the range of 0 to 1. So that is what I will do now. So now you can see my entire data is nothing but 0 and 1. So my maximum value is 1. So if I have to map my 6.4, that is nothing but my sepal width of versicolor. So what is my versicolor? It is green. So sepal width of versicolor should be somewhere around 6.4, but my maximum range is 1. So I will fit my entire data to 0 to 1. So 6.4 would come somewhere close to 1. So similarly, if I want to plot my sepal length of Sentosa, so sepal length of Sentosa is 4.9. So 4.9 would come somewhere around 0.75. So this is how I plot the data. So if I have some Virginica data, it is 5.9. 5.9 would come around here. Okay, next what I will do is I will try to nothing but map my petal width. My petal width, the maximum value is 1.8 for Virginica. So 1.8 is the maximum value. So it would range from 1. So it would range near 1. So it is a rectangle. So you need to draw a rectangle here. So what I need to draw now is a rectangle of an orange color, which is telling it is a petal width of Virginica. So now if I want to map my petal width of Sentosa, which is of red color, so it would come somewhere around 0 because it is belonging to 0.2. But the maximum range that we are considering is from 0 to 1. So this is very important. So versicolor would come around 1.4. So it would come under 1.2. So 1.2 would be nearing my axis, that is around here. So now what I can do is I can compare all my features. So if I wanted to find out what would be the k nearest value or what would be my value, so here I can consider different features. I can consider my sepal width also, I can consider my petal width also. So that is why I am telling you, you need to do the standard scalar operation. So what standard scalar operation does is converts all the meeting to 0 to 1. So that is what it is doing. It is converting all your values to 0 to 1. So that is how it is able to actually map all your values. So if you don't convert it into 0 to 1, you will have values at different places and you can't take in consideration of all the values. So very important to apply your standard scalar operation. So what is the standard scalar and how to apply it? It is pretty simple. So we have a standard library from sklearn itself. So you can use the sklearn library to actually use that function here. So what I will do is import, or from sklearn, we have from sklearn.preprocessing. So from sklearn.preprocessing, import standard scalar. So we are basically converting all our values to a standard set of values. So that is what we are doing. So what we'll do is we'll name a variable called a scalar. So that scalar is nothing but our standard scalar. So it is our function, that is the standard scalar function. So instead of using standard scalar name every time, so we can use scalar name each and every time. So what we need to do is we need to fit our value now. What is the value that we are fitting here? So we need to fit our xtrain value. So why we need to fit our xtrain value? So similarly, because we need to actually use this data, that is nothing but we need to fit our data. So what is meant by fitting? Fitting is nothing but telling us which is our data. So why we need to tell which is our data? In order for our scalar function to understand what is the range. So now you have the data, that is nothing but the data that is available. So but once you consider the fitting of data or training, you need to tell the algorithm. So you need to tell the scalar function. So what is my x value? So the scalar function will understand that x is nothing but 4 columns. So each and every column will have minimum and maximum range as so much, and the algorithm needs to convert that minimum and maximum range from 0 to 1. So that is why you need to fit the data. Which data you are fitting? You are fitting the xtrain data. So what this fit is doing is training our standard scalar function. So training that these are all the columns that I have in my x-axis, that is nothing but my x coordinates, or x data is nothing but all this data. So I need to actually fit this data to my value so that I am able to retrieve the result. So what is meant by fitting data here? Training or understanding that this is my minimum and maximum value. My value should be scaled down to 0 to 1 if it is greater, or if it is just below my range, so it needs to be also again scaled up to 0 to 1. So all the values are getting scaled to 0 to 1, however large they may be. So that is why you are using this. So you are giving xtrain data to understand what data we need to scale and what is the column that we need to scale. Okay, so after fitting it, we need to apply the transform, right? So how will we apply the transform? It is simple. So we'll use the xtrain again. So what we'll do is we'll save xtrain as nothing but scalar dot transform of xtrain. So what is scalar dot transform? So we are transforming the data. So here we just trained the data, but here we are actually transforming the data. So what we are doing, we are transforming our data xtrain and we are saving it in xtrain only. So then we have our xtest. So xtest again we are transforming the data and we are again saving it. So we have transformed our xtrain and xtest data and we have saved it. So what this function did, I already told you, converting everything to a smaller range so that all the data will be in the same range. So for comparison as well as for finding the nearest neighbor. So this fit function, what it is doing, fit function is basically is the training function which undergoes the training, but you need to mention from where it needs to undergo the training. So xtrain is nothing but a huge data set which contains all the x columns, sepal length, sepal width, petal length, petal width. So this will undergo the training. This is the training data. So this is telling that my maximum range and minimum range is depending upon the columns is belonging to the xtrain data. So then what we are trying to do is we are trying to transform the data of xtrain and xtest. So why we need to transform? This is just the training part. This has understood what is my maximum and minimum value, how to transform. So now we are actually transforming our xtrain and xtest and we are storing back them in xtrain and xtest. So this will have my transformed data. So if I try to print my x underscore train now, so what is the data that I will have is pretty simple. So if I can try to print out the data, so it is just giving out me an error. So what is the error? Okay, one small spelling mistake here. It is scalar. E is it is not A, it is E. So it is a standard scalar, so that we need to use E here. So this can be named as anything. So we'll try to run the code. So SCALER is the actual spelling that needs to be used. So not SCALAR. So it is SCELAR. So this is important. And here also I need to change. So from sklearn.import standard scalar. So here also I need to change. So 2 places if I change, then I would get my correct values now. So now my data is squeezed. So this you can see that all the data is getting converted in the range of 0 to a range. So this is telling you that it is getting converted. So just for an example, I told you it is 0 to 1. But actually how it does is it compares all the values, that is nothing but each and every column and each and every data. For representation I told 0 to 1, but it is not actually 0 to 1. Based upon all the data, it calculates and it does an average and performs the scalar transformation. So based upon that, it is converting each and every value to its equivalent. So if I have all the column data, it will consider each and every column data and each and every value, and then it will transform them to their equivalent value. So that is what we are having. So we can have negative values also as positive values also. It is not 0 to 1 every time, but for the sake of my explanation, I gave it as 0 to 1, but it can be different values Based upon the average and mean values, it will calculate after adding all these particular each and every column data. So we have successfully got our scalar data set. So this scalar data set is helping us actually use that data for each and every operation, and this is an important thing in k nearest neighbors. But in other examples, we didn't use our standard scalar transform because we don't need them in other sets. So in other data sets, data will be considered separately and we'll draw a graph in other, for example, in our logistic regression. So data is automatically going into class 0 and class 1 for each and every separate column that we have. So here, since we are considering our nearest neighbor algorithm, so we need to use our scalar transform each and every time. So if you don't use them, the problem is we are not able to actually get the best results out of it. So now what we will try to do is, we will try to use our k nearest neighbor algorithm. So we have from sklearn dot neighbors. So import k nearest neighbor. So k is caps, n is caps, NEIGHBORS. So that is the k nearest neighbors. So k neighbors classifier is the name of the function. So what I will do is I'll use another variable that is nothing but classifier. So classifier is equal to my k nearest neighbor. So you can copy it if you have if you can't type it, you can copy this and paste it, k neighbors classifier. So that is your classifier. So here you can use that, but here I need to mention my nearest neighbor. So n underscore neighbors, I need to mention how many data I have now. So what is the value of k that you will choose? So since we are predicting, that is nothing but you can choose two things. So since my total sample is 150, I can use my 12. So this is also possible. So square root of 150 is 12, or you can use any other value which you want to. Since the data is large, so there are less possibility of errors that are coming to happen. So you can use that values as such. But according to the convention, I can use it as nothing but 12 because I am telling you that the total data that I have is about 150 flowers. So the square root of 150 would come around 12. So 12 is a good number to use. So that is why I use number 12. So I have defined my classifier and I have told that it is a k nearest neighbor classifier. So I have told that the nearest neighbors is nothing but choose 12 nearest neighbors. So that is what I have told. But I need to fit my data. So what is the data that I need to fit? X train and Y train. So Y train and X train, why we need to fit? Because this is the training data and our algorithm needs to get trained for this data. That is why I am using this. So after doing that, I need to predict what my algorithm predicts. So y underscore predict is equal to classifier dot predict. So what data it needs to predict? X underscore test. So if it predicts X underscore test, so that is the value that you are getting. So this, if you try to print out, so it will try to print out what is the data that it predicted. So you can see here, so we can print out the y underscore predict now. So y underscore predict will print out the actual, that is nothing but the algorithm predicted value. So this is our algorithm predicted value. So it is able to print out Virginica, Versicolor and Sentosa. So that is what it is able to print out here. So this is our y prediction value. So this is how you actually implement a k nearest neighbor classifier. So first thing is take your data, split your data into X train and test data you already know. But one more operation is standard scalar. It is very important in this algorithm because you are using this algorithm in a different way. This algorithm works in a different way. That is why you need scalar transformation to transform your values of different columns to a matchable column. So that helps you classify all the features. You can consider all the features. Now to see which one is correct, that is nothing but we'll see our confusion matrix. So what is confusion matrix? That is telling you how many is wrong and how many is correct from the total number of predictions that it has made. So what we'll do is from sklearn.metrics import confusion matrix. Confusion underscore matrix will import that. So from sklearn.metrics import confusion underscore matrix. So what I will do is I will print my confusion matrix. So confusion matrix of what data? Y underscore test comma y underscore predict. So this is telling me the predicted data as well as the test data. So predicted data is the data that is predicted by the algorithm. Test data is the data that we have actually split our y data into y test data. So this is how we can print out the confusion matrix. So what I have done is I need to add another brackets here. So now you can see that our data is getting predicted. So we have out of our data that is nothing but how to understand this confusion matrix is pretty simple. So this confusion matrix is belonging to three classes now. What is the three classes? Sentosa, Versicolor and Virginica. So how I can tell this as Sentosa, Versicolor and Virginica? It is based on our alphabetical order. So according to the alphabetical order, Sentosa is first. So this is the Sentosa. So out of 9 data of Sentosa flowers that were gone for prediction, so 9 were also predicted properly. So it is 100% accuracy in case of Sentosa. So then we have nothing but our Versicolor. So why Versicolor? When we compare Versicolor and Virginica, alphabetically it is forward, so it is Versicolor. So out of again 9 Versicolor samples, 9 were also predicted properly. But when we come to Virginica, so we had 12 samples of Virginica. In 12 samples of Virginica, what happened? 10 samples were predicted as Virginica only, but 2 samples which belong to Virginica were predicted as Versicolor. So this is how you need to understand. Here we have 3 classes. One is nothing but Sentosa, Versicolor and Virginica. So what is happening now is pretty simple. So we have Sentosa, Versicolor and Virginica. Sentosa only we had 9 data, out of which 9 data were also predicted as Sentosa. 0 wrong predictions here and 0 wrong predictions for our Virginica also. Similarly, we had our 9 examples or 9 sets of data which were belonging to Versicolor. So 9 were also able to be predicted successfully as Versicolor. But here we had 12 data of nothing but my Virginica data. But in 12 data, 10 were predicted successfully, but 2 were predicted as wrong data. That is nothing but instead of predicting Virginica, it was predicted as Versicolor. So this is how you need to understand. 0 is telling that no wrong prediction. This 2 is telling that it is predicted wrongly and it is misclassified into Versicolor. So this is how you implement a k-nearest neighbors machine learning program. So I hope you have understood this program successfully. So I will be posting the code and you can try it out. Since there is no dataset available, you can use the URL directly to obtain the dataset. So thank you guys and have a wonderful day.